Okay, guys, here we are, 5.2. We're going to talk about best fit lines. Back at it. Here we go. All right, so best fit lines come up when we are talking about scatter plots. You guys are familiar with scatter plots. You've worked with them before, right? Right. This table shows the time spent playing video games daily for different age groups or different ages. So we are just going to plot everything on here. I already gave you the title, age versus time spent gaming. Your x-axis is age in years. Your y-axis is time spent daily playing video games in minutes. So, Marina wants to say hi.
Hi.
Um, all right, so our first one, 1085. I can't see where I'm rating. Here we go. Still can't see. Me. 1085 right here. And then 1575, 20, 80 minutes, 22, 78. Okay, you guys go ahead and finish these up. Okay, so all of your points are now plotted, and we want to look for a pattern. We want to see if we can tell, is this a linear graph? Is it nonlinear? Linear, of course, meaning is it a straight line? Nonlinear, is it not a straight line? I'd say this looks definitely linear, and I would say it is looking like a negative slope. So we have a linear graph happening. It has a negative slope, so it's a negative linear um, problem that we are looking at. The line of best fit, which is what this section is all about, also called best fit lines, is what a straight, a linear, nice line can we draw in these points that's going to represent this data very well. When you draw these lines, you don't necessarily have to go through any points at all, but you want it to be the best representation of all the points. So maybe you might draw something in like that. Maybe you would have had it more up this way. So everybody's best fit line might be just a little bit different, but certainly we wouldn't want something like that. Like that's not representing your data in any way. So you want to stick it through um, your points in general. Maybe there. That's a good one. Okay. Looks to be about the same amount of points above as below. It does end up going through a couple here, but again, it does not have to. Okay, so our next graph, it's the age versus time spent puzzling. So we're talking about how many puzzles you are completing throughout the year and what age you are. I don't know what kind of puzzles these are, but does this look linear to you? What do you think? I'm going to say it's nonlinear. Okay, it looks like there's a curve in it. Nonlinear. So I couldn't draw in a straight line. I mean, I could, I don't know, that. Or maybe I could look at just the first part of it and say, oh, well, that part looks like a straight line. But this data here would definitely not be represented by this line. So we can't really have a good line of best fit here. There's no good best fit line. And that's because it's nonlinear. So we do not want to draw one in if it's nonlinear. Again, if it's nonlinear, do not draw a line of best fit. We actually might be able to come up with a model for this that is something called quadratic, but we haven't learned that yet. We'll get to it here in a couple units, but it's going to be something like this that comes down and then comes back up. That's called a parabola. We can also analyze the data in these graphs. We can talk about what's happening. So going back to this one, we could make a kind of generalization that the older you get, the less time you spend playing video games. Okay, that's what this data is showing us. And in this one, we are seeing that as you get older, the puzzles you're completing per year go down up into a certain point, maybe about 55 years old. Then you start increasing the number of puzzles you are doing per year. Okay, so we're getting some data analysis from our scatter plots. We also want to talk about the, move that over, the correlation that is happening here. So these first three graphs on your paper, they have positive correlation. So correlation is do they have a relationship? Positive meaning as one increases, the other increases. So that would be the opposite of what we had here. This is a negative slope, which means a negative correlation. Positive slope indicates a positive correlation. This first one is a weak positive correlation. So yes, we can see that in general the points are increasing, but there's also some ones, maybe we could even think of them as outliers, bringing in a word from last unit. The middle one, we have a medium positive correlation, or a moderate. You could also use the word moderate. And then the last one is the strongest one, so we call that a strong positive correlation. So the closer they are to making a perfectly straight line, the stronger the correlation is. Okay? We can say the same things about the negative. So this is a weak negative correlation, a medium or moderate negative correlation, and a strong negative correlation. So again, the closer they are to being in a perfectly straight line, the stronger the correlation is. It's also possible to have no correlation at all, and that is when you can't put a line in there. You can't find any best fit to happen in here. So it doesn't matter like where the dots are. It's just that you can't figure out like, should I put a line this way? Should I put a line this way, this way? We don't really know. There's not a good pattern or a good relationship happening. Okay, so this one is no correlation. Okay, now we're going to use the graphing calculators to construct scatter plots. So if you are watching this at home, you need to watch this part of it at school with a graphing calculator if you don't have one at home. Okay, so press your home button. We need a new document. Yours probably pops up and asks if you want to save it. You do not need to save anything. You want to go to 4, Add Lists and Spreadsheets. Okay, and then we want to enter the data from this chart into this chart. This is your steps for entering data. You want to write that down if you don't already know that. So we need to arrow up to get to here. This is where we're going to name it. This is going to represent your total fat, so I am just going to call that fat. We don't want anything in the equal box, and then this is where we will type the rest of our data. So 9, 13, 21, 30, etc. So fill in the rest of your data and then do the same thing for column B. We're going to call that one, let's just call it cal, C-A-L, for total calories. Pause the video and finish your chart. Okay, so you have all of your data put in there. Be very careful when you're typing. You don't want to have anything entered wrong. Make sure you have the same number of data points on column A as you do in column B, since that is the way your chart is. So just double check, going and making sure you have all of your data set in there correctly. Okay, so now that all of your data is in there, I'm going to show you 2 different ways to do a scatter plot. One way is if you have the equation for the line of best fit already, and one will be if you need the calculator to tell you. I want you to know how to do both, and I'm going to show you how to do both on this problem. Okay, I've changed my directions over here, so if we already have the best fit line equation, which we do, it's given to us right here. To get a scatter plot, you want to go to Control Doc, which is going to add a page to your document, to add graphs, and now we need to change this. We don't have just a normal function, we need a scatter plot there. So menu, graph entry, edit, scatter plots. Okay, then we need to type the name of our x and our y variables. So we called our x a variable. If you remember in our list over here, we called it fat. So we need to type in fat right there. And for our y variable, we're just going to arrow down, get your y variable, and if you remember, we called that cal for calories. So oops, erase it. Fat in our X value, cal in our Y variable, and then press enter. Okay, it doesn't look like anything, but that is just because there's no data in our window that we currently can see. So to change our window, let me scroll this down here. So this part here is changing right here, is changing your window. So we're going to press menu, window zoom, and zoom data. That's going to zoom in just on the data we have. And there you go. You can see your scatter plot. You can see that we are talking about fat for our X values and calories for our Y values. Now, to see the best fit line, we want to draw our line in from the equation that we already have given to us up here. You're going to press menu, graph entry edit, and we need to change it back to function. Then we can just type in our equation like we always do. So 12x plus 193, press enter, and there's our best fit line drawn through our scatter plot. So we can see from our data that as your fat, what are we in grams? Fat grams increase, the total calories increase in a pretty good linear function. Okay? All right, now let's say that we were not given this equation. Your calculator can come up with it, and it's actually easier for linear anyway. It's pretty easy to do. Okay, so let me switch those directions. So using the calculator where we were, totally fine. We want to put a scatter plot in a different way. Okay, so we're going to go back to Control Doc to add another page. And this time we're going to add data and statistics. This looks like a scatter plot, but it's not. It's just the data is randomly put there. So we need to tell it where we want everything. So we're going to click to add variable, and we know our X variable is fat. So select fat. It moves it, but it still doesn't know what the y-axis is, so we need to tell it that as well. Click to add variable there. Our y-axis is calories. Click that, and now you have your scatter plot. Okay? To get the calculator to give you the line of best fit, you're going to press menu. I left that out. Let me put that in here. Menu. Four for analyze, 6 for regression. That's what this is called. And we know we're working with a linear scatter plot. So show linear, we want it in y equals mx plus b form. And as soon as you do that, it draws your line in, and it even gives you the equation. So you can compare that equation to what we had up here. The calculator came up with 11.7313. Those numbers probably went on and just rounded it off. And then we ended up rounding it all the way to 12. The y-intercept, 193.852. We rounded to 193. So this graph is actually a more precise one than this one. The line of best fit would be just slightly more accurate. Okay, so two different scatter plots. This first way, again, is if you have the equation, you can just draw it right in there. And the second way is if you want the calculator to come up with the equation. Again, you need to know both, so make sure you have both sets of directions there on your paper. Okay, let me stack these all out of the way now. All right, so predict the calories of a sandwich that has 18 grams of fat. So we could look at our graphs. Maybe you're looking at this one. Here's 16, here's 20. That means this is 18. So we can just use our scatter plot and say that, well, that's right here. That's 360, that's 440. I'd say that's about 380 calories. Maybe you were looking at this one. This one's going to be a little bit harder to see because you are counting by, oh, I don't even know. Are you counting by ones? It's hard to see. So this one you can pull it right off. So it's actually nicer when you have the calculator come up with your best fit line. That's just the way this calculator is set up. On other calculators, it's easier to have the equation already and type it in. But Either way, so maybe if you're looking at just this graph and you're like, I'm not really sure, I can't really tell. The other thing you can do, if we know that there's 18 grams of fat, well, our fat then is 18. Fat is your x-axis, or your x variable. So if x equals 18, essentially what we're trying to find is our y. So y equals 12 times 18 plus 193. Y equals 12 times 18. Let me pull up my other calculator. And then plus 193 gives me a value of 409. How did that stack up with our graph over here? I don't remember what we said it was. So when I was looking at this one, we came up with about 380. So a little bit off, but not far off considering what you're working with. Make sure you label 409 calories. Okay, predict the fat grams of a 400 calorie sandwich. So we know there are 400 calories. 400 calories, calories being the y variable. So if y equals 400, what is your x value? So if we just look at the scatter plot, 360, 380. Oh, I did that wrong, didn't I? That halfway point was 400, right? Because 360, 440, halfway between that would be 400. So I looked at that a little bit off. So 400 should be right about the same thing. It should be somewhere around 18. Let's find it out using our equation they gave us. 400 equals 12x plus 193. We need to solve this. So we're subtracting 193. 400 minus 193 is 207. And then we would have to divide by 12. 207 divided by 12 gives us 17.25. So very close to the 18 that we thought up here. Okay? So just two different ways to do it, whether they give you the equation. If they hadn't given us the equation, we would have just used this equation. Probably rounded it 11.7, 193.9 maybe. But that's what we would have plugged into had they not given us that one. Okay, the next problem asks us to predict the calories of the grilled cheeseburger. So it's 2 grilled cheeses and a burger. And it has 79 grams of fat. Well, if you look at our data, we didn't have anything close to 79 grams of fat. Our highest was what, 34? So this is called extrapolation. Okay, this is when you are looking at predicting something that's outside of your data set. So we could use our model back here to predict things that are within our data set. 18 grams, that was within our set. 400 was within our range in our set. Okay, but 79 is not. So if you're doing that, you can't necessarily be very accurate with that, and that's called extrapolation. Okay, so it's not a good idea to do extrapolation usually. Sometimes this is how you get some bunk science, where people make claims that aren't true, and it's because they're predicting something so far out of the information they're given that they cannot be accurate. Okay, one more. Okay, whoops, I'm on the wrong screen here. This scatter plot shows the price of stamps over time. Time is in years since 1900, so be careful with this. So x equals 20 doesn't mean the year 20, it means 20 years since 1900, which would be 1920. So 1910, 1920, all the way up through 1990. They're giving us the equation of the best fit. Notice now they're not calling it a line, they're calling it a curve because these red dots, those are definitely not a line. They're not a perfectly straight linear line, they are a curve. So we can't use y equals mx plus b, which no surprise, this is not in that form. Okay? The problem with this is going to involve things like you need to know shapes of graphs that you don't know yet. So when you're doing this, sorry, I just bumped the microphone if that made a loud noise. The problem with it is you can't do it you can't do it the way if you don't have, like, to have the calculator give you the best fit line, because you don't know what it's called. If it's not linear, you have to know what shape it is, whether it's maybe something called exponential, quadratic, cubic. You guys don't know that yet. So if it's not linear, we're only going to do the method of we already have the equation and you have to use it this way. Okay? So I want you guys to pause the video. I want you to enter the scatter plot in your calculator. I want you to put this as your best fit line equation. Again, so you have to follow those directions where you've already been given the equation. And then I want you to use your scatter plot and your equation to answer these questions. So pause the video and get that done. Okay, so using the equation to predict the price of the stamp in 1940. So the price of the stamp is the Y, and the time since 1900 is the X. We've been given the year 1940, the time since 1900, then X equals 40. So we're plugging 40 into our equation. Y equals 1.1 to the 40 minus 50 plus 2. Let's go ahead and go in our calculators, calculate that. Let me just go back to my calculator screen. So 1.1 caret key to the 40 minus 50, arrow over to get out of that, plus, I can't see, 2, gives us an answer of, let's round it to the nearest, well, we're working in cents, so we can round it to the nearest whole number, and we would get an answer of 2 cents. Okay? For the second one, the actual price of a stamp in 1972 was 13 cents. How far off is this model's prediction? So that's what we use scatter plots and best fit lines to do, is we use them to predict things. However, we can also compare that prediction to the actual what something was and see if your prediction, if your model is a good model or a bad model. So in 1972, that X value would have been, how many years is that since 1900? 72 years. So now we're going to do Y equals 1.1 to the 72 minus 50 plus 2. Calculate that one. 1.1 to the 72 minus 50, arrow out of the exponent, plus 2, gives us an answer of 10 cents. Okay, so we got 10 cents. The actual price was 13 cents, so we're off by 3 cents to answer that question. Okay, and if you look at 1972, should be just over a little bit. There's that data point right there, maybe. Okay, at 13. And you can see that it's just a little bit off of the line. Okay, it normally would be right here. That would be our 10. All right, so some good stuff about scatter plots. We're going to talk more about them in the next section. But go ahead and, again, if you were watching this video without your calculator, you need to make sure you go back to this stuff and you get all of these instructions down on how to put a scatter plot and a line of best fit in your calculator. Okay, go ahead and work on your packet.